And I'm not starting with the last two. I'm not starting with the last two. Let's start with up front. Which one do you want to talk about? 21. What do we got here? Single variable. What are we at? 9 point something? 9 point what? 3? Is it that one right there? Yeah, I think we got to start with 21. This one right here? Unfortunately, we do. Okay, so kids, some of you might have. How many of you actually worked on this one? And how many of you actually worked on this and got somewhere, they think? Somewhere. Okay, so first question for those of you that started it, what tests are you using? Like, how are you seeing if it converges or diverges? What are you going to use? What's it called? What's the name of it? The integral test, right? You're going to evaluate what integral. What integral are you going to evaluate? The integral of what?
3 over x squared.
Yeah, 3 over, we could say, whatever, x squared plus 4 dx, and what are our limits? 0 to infinity, right? What type of integral is this? What type of integral is this? Do you remember? I gave you indefinite. Yeah, it's indefinite. We're going to talk more about that today, but it's an indefinite integral. You can't plug in infinity, right? It's not something you can plug in, so you have to turn it into a what? We're going to anti-differentiate it, but we did one of these already. You have to turn it into a limit. Do you remember what we did? So we said something like this. The limit as b goes to infinity, 0 to b, of 3 over x squared plus 4 dx. So your whole goal is to try to integrate this. If you can actually find an answer that isn't it blowing up, it converges. If this blows up, that the series blows up, so it diverges. The challenge is the bottom here. What can you factor out at the top? What don't you really care about?
3.
You don't really care about 3 in the grand scheme of things, right? Can 3 affect the convergence or divergence of this sequence? No, it can't. So this right here, you might look at it and say, oh, I might want to try using U substitution. Do we want to use U substitution?
No.
Why not?
There's no x.
Yeah, it doesn't work, right? The degree of the top is 2 less than the degree of the bottom, so nothing cancels. What does that almost look like, though? What does it almost look like? Yeah, okay, that's fair. It almost looks like the difference of squares, so maybe you can do partial fraction different, you can break it apart. It almost looks like arctan, right? It almost looks like arctan. And just to remind everybody, what's the first derivative of tan inverse of x? What does that equal?
1 over 1 plus x.
Yes, that equals 1 over 1 plus x squared. So if you integrate both sides, tan inverse is equal to the integral of 1 over 1 plus x squared dx, right? So what's the one number that makes this just a little bit more entertaining for us? The 4. That 4 kind of makes it entertaining. We don't like it, though. We just don't. It's not cool. So you know what I'm going to do? I'm going to factor out 4. I'm going to be 3 over 4 times this limit. Yay! And what does it become? 0 to b, 1 over x squared over 4 plus 1. Right? Are we almost? Oh, we're almost there. What can we rewrite x squared over 4 into? Wait, 4? What? What'd you say?
4
Not quite. We're not going to flip it yet.
x over 2.
Ah, who said that? Up front there, nice. Is that the same thing? It is. Now what can we use to keep track of all of our coefficients? Now we can use what? Now you can use U substitution. So let's say, what do we want U to be? What should U be? X over 2. So if that's true, what does du equal? 1/2 dx. So what does dx equal? 2 du. Now that we've figured out what u is we think it's supposed to be, now we get to do the substitution part of U substitution. You guys called it W substitution, right? I think U substitution. So now we take this, and what does this now become? 3/4 the limit as b goes to infinity, 0 to b of 1 over u squared plus 1. But instead of dx, what do we write? 2 du, right? There's 2 of them. What can we factor out to the front? The 2 cancels with the 4, leaving us with what? 3 over 2, the limit as b goes to infinity of 0 to b of 1 over u squared plus 1 du. Now are we happy finally? Are we finally happy? Are we in a good place in our relationship with this problem? Those of you that are busy writing things down, stand up. Right now. Just the people who are busily writing things down. Stand up. Stand up. That was you. Yes, I saw you right. Stay standing until I say you can sit down, okay? Can we now actually do the integral?
No.
We know what it is now, right? So now what do we have? 3 over 2 times the limit as b goes to infinity of what? Tan inverse of u from what to what? So what is that going to be? 3 over 2 times the limit as b goes to infinity of tangent of b, tan inverse of b, minus tan inverse of 0. Now you need to remember what tan inverse looks like. Now you need to remember what tan inverse looks like. Do you remember what it looks like? Looks like an S, right? Tan inverse looks like a flat S. It goes like this, right? Really terribly drawn. But where does it pass through? Origin, right? So what does that tell us about this? What is that equal to? 0. Is there a horizontal asymptote here? At pi over 2. So what does this go to? Pi over 2. So this whole thing equals 3 pi over 4. So what does that tell us? Hey, we came up with an answer for this integral, so therefore this thing converges. Done. Yes, this one's a pain in the butt. Yes, it is. You can sit down as long as you stop transcribing everything I write, because you're literally getting live access to what I'm writing it down. It's a redundant waste of time.
But some people learn better by
I learned better by repeating the same thing.
I understand. Then I'm going to keep on hitting you with deep questions, and as long as you can answer the deep questions, then you can keep on writing things down. Fair enough?
Did we have to do the integral?
Important, and also because I probably haven't said it yet. Just because the solution is easy to understand doesn't mean it's easy to find. Does that make sense? Hey, remember that recursive series on that quiz I gave you a couple days ago? Kind of pissed you off, huh? I'll show it to you eventually. Here's the thing. It asks you, does this converge? Kids, to say, I'll give you a hint, that allows us to break these apart, right? So it's 2 different sums.
Oh my gosh, I did that.
Okay, congratulations. Good, good. Of this, right? What type of series are those? And that's not an n, that's a 2. What type of series are they? No, what type of series? They are both what? Geometric series. And you have a very simple way of knowing whether a geometric series converges or not. What is it? Yeah. What is the r in this case? 1/2. What's the r in this case? 2/3. Both of these have an absolute value less than 1. So therefore, converge. Yay! They're both.
What if you do that without doing that work? Because you saw both geometric.
Yeah, you can literally just say, if you had written down, if I gave you this, if you had said, it's the sum of 2 geometric series that I know converge because the r values are both less than 1, you're all set. Go with what you know. You know these are geometric series. You know a very simple way to know if they converge or not. What happens if that was 3/2 instead of 2/3?
Then you
It definitely blows up, right? It definitely blows up.
Either one is converging.
So what happens if one is convergent and one is divergent? What would you say about the whole thing? It diverges. Like, divergent plus convergent is divergent. Convergent plus convergent is convergent. Divergent messes things up, including the movie. Okay. What did people try to do? What's a maneuver someone did?
use of
Hmm?
is that a thing?
Well, you can't really use. I mean, you tried to. Okay, so you tried to use the integral test.
Yeah.
Yeah, if you try to use the integral test, it doesn't really work, right? Nothing really. You don't really have an integration method. You need to remember basic algebra and things you can do to help you out here. This is the same thing as it's n equals 1 to infinity. Hold on, I gotta get a better pen size on this. It's 1 to infinity. Can you break that apart into 2 fractions? Yeah, n equals 1 to infinity of what?
1 over 2 to the
Hmm?
1 over 2 to the n plus 2.
Yeah, look, if you actually, so what's interesting about this actually breaks apart into 1 over 2 to the n plus something. If you can see it, it's hard to see. Plus what?
1 over n.
1 over n. It breaks apart into 2 here, right? Are you with me? Do you see how that's true? Yeah, if you get a common denominator, you have to do n. If you put an n right there, that's where that comes from. You have to do 2 to the n, so it does break apart. So now we're going to look at each individual one individually. What do we know? What do we know about this one right here? It diverges. Correct? So does it matter what we add to it? It would still diverge, right? Are you with me so far? Do you understand what's going on here? So this right here is equal to the sum n equals 1 to infinity of 1 over 2 to the n plus the sum from n equals 1 to infinity of 1 over n. What's that series called? What's the name of this one? 1 plus a half plus a third plus a fourth. What's that called? Harmonic, right. Does the harmonic series converge? No. What does it do? Diverges. So we know that this right here blows up. We actually know what that does. What kind of series is that? What is it? It's a power series. So it's going to be 1/2 plus 1/4, right? Plus what? 1/8 plus what? So another way to say this one is actually, what's the ratio? It is also a geometric series. What's the R value on that one? The R value is 1/2. Absolute value of that is less than 1. So we have a convergent and a divergent added together. What did we just say that? What happened there? It diverges. It diverges. It blows up.